Good afternoon. The pleasure of talking to you guys right after lunch, so try and keep you guys awake. We got these guys are setting up a demo of some of our smart storage technology. My name is McLeod Glass. I run our worldwide product marketing team for all of the DL, ML, and all of our smart storage products, as well as some of our host side networking components within those servers. And I'm going to talk to you today a little bit about the application performance acceleration and one of the key tenets of what you saw previously from some of our Gen 8 value prop. And we're going to go into some of the details on some of the technology behind that. So I'll start with just talking a little bit about kind of the problem, right? So there's really, several different areas that customers are experiencing a lot of issues when it comes to dealing with application performance. If you look at the digital content explosion, it really causes a unique problem. First, starting with on the performance side, if you look at our customers, some of the customers, like a leading e-tailer, processes about 75 billion transactions on a daily basis. So really high performance requirements. You look at on the capacity side, 2011 from digital content, we delivered about or created about 1.5 zettabytes of data. Looking forward to 2014, that could go as high as expected to go as high as 7 zettabytes of data being created on an annual basis just from digital content. So that's performance and the capacity side of it. And then if you look at it doesn't really isn't really help you to drive all that performance and capacity if you can't protect the data as well. So one of the numbers that's that we've seen is around $10 million on an hourly basis from a total business impact from unplanned downtime for businesses on an average basis. And so it's very important that not only you drive the performance requirements of the application at the right capacity, but also to be able to deliver that in a protected way. So if I look at, let's see here. Sorry about that. One of the challenges is that if you look at how processor and memory performance has increased over the past few years, it's continued to move at Moore's law. So continuing to advance in terms of performance. And we've seen significant advancements from a compute and memory standpoint and from an I/O standpoint over the last few years, while storage has continued to lag behind that in terms of the performance gains. A great example of that is if we look at our performance labs, Mike Nikolaev runs our performance engineering team. And when we did the G5 servers, his job is basically to drive the best possible benchmark performance number from our products. If you look at the G5 products, it took him about 180 spindles to drive that top performance benchmark. As we went to G6, it took him about 1,200 spindles to drive that performance benchmark. And in G7, it took over 2,000 spindles to drive that performance benchmark. So when it came to our Reliant Gen 8 servers, we didn't have enough spindles in the building to really drive that higher end performance number. And so we had to go address that. And the way we're addressing that is through a couple of things. One is adding intelligence into the storage subsystem and really optimizing around solid state. To really go close that gap. We were able to drop that total number of devices from in the thousands down to 100 devices to go drive that benchmark through the optimizations within the smart array system itself combined with the solid state. Together, if you look at that combination, it drove it was a 75% reduction in overall space and an 88% reduction in the energy consumed to go drive that. So big savings in terms of driving those the solid state optimizations, and is a big part of helping us close that gap from a storage standpoint and increasing the overall performance of the storage within that subsystem. So he's still booting up here, but so that on the demos today we got a couple of things. One is a performance um, uh, uh, demonstration. We've got solid state running in the server itself, so you'll be able to take a look at some of those performance gains from the standpoint of seeing it firsthand. And then I've got some other demonstrations on data protection and some of the technology advancements we've got there. So if you look at capacity, one of the obviously big things is the fact that there's been increased capacity demands from different applications. As I mentioned before, I talked about zettabytes of data being created, but not all applications have the same data requirements. And so one of the things that we did with our Reliant Gen8 portfolio servers is it's a very modular design from a storage standpoint, and you see here in the picture the different front ends that you can get with each of the Reliant. This is the DL380p Gen8. So you can match the right storage footprint to your application needs, and at the same time driving a very standard experience from being able to use the same server to go do that. Same management experience, same overall experience, but just have the right size storage footprint for that server. And so we've got in some cases 50% more spindles and over 2x the storage capacity. We can deliver up to 36 terabytes of storage in a single 2-use server with this new modular design. Like I said, the big benefit here is better storage density, but also driving the overall customer experience to in the same type of product, same product that they would use across those different applications. So just looking back at on the history of Smart Array and on our RAID stack in general, back to 1989 when we first introduced Reliant, we introduced the first RAID stack integrated in that solution. Building on that heritage, we've eventually introduced advanced data guarding, which eventually became or is known as RAID 6 across the industry. We're the first to deliver that. And with our Reliant Gen8s, we also we've introduced advanced data mirroring, which is a 3-drive mirroring technology that allows you to better protect your data at the same time without having to compromise performance. Part of the reason why that's important is if you look at the capacity growth of an individual drive, where we're up to terabyte drives and larger, it's harder. It's actually the issue is not if I've got a mirrored set and I have a drive fail. It's not the probability of a drive failure that you have to worry about. It's the probability of a bit failure on that other drive once the drive has failed. And so advanced data mirroring really addresses that issue in particular, where if you've had a drive fail and you've got the other drive and you've got to go in and replace that drive, the probability of having a bit failure on that single drive being unprotected because of the size of the drives themselves, it can be a real problem. And so advanced data mirroring actually takes and has 2 separate copies of the data to allow you to protect your data in that way. A good example of that is if I look at NASA, right? So NASA typically requires 3 systems, just different systems on every vehicle that they use, and the reason why is because it essentially reduces their probability of failure of that particular system down to 0 because they have 2 redundant copies of that. And so in a very similar way, advanced data mirroring helps protect your data, and from that standpoint. I have a question? Yeah.
RAID 6 obviously has a pretty significant write penalty.
Right.
Advanced data, what kind of a write, or I don't think there'd be a read penalty, but write penalty do you see with advanced data mirroring?
Generally speaking, your write penalty is going to be a function of the number of IOs that you have on the back end of the RAID controller. So with RAID 10, where you're keeping 2 mirrored desks, there are 2 IOs, so your write penalty is roughly 50% compared to like a RAID 0.
So it's still like mirroring, but
it's
like
like
right.
mirroring. So
Okay.
with RAID 10 with advanced data mirroring, you have 3 disks that you got to mirror, and so you're down to a 66% write penalty because you got to do 3 IOs per
Okay.
disk.
So it's still better than RAID 5, but not
Right.
as good as RAID 1 or 10.
Correct.
Okay.
It's in between in terms of from a performance standpoint, but at the same time you're increasing your resiliency, right?
And so you also have a capacity. You're using there's a lot of capacity overhead with
Correct.
as well. Okay.
Correct.
Great.
Yep. Yep. And so, in the demonstration, we're going to actually have, we've got advanced data mirroring as one of the demonstrations that we've got here, and we'll also demonstrate the smart drive, or the HP smart drive as part of what we delivered in ProLiant Gen 8. And I actually have a demonstration animation here. I'm going to play it for you real quick, and then we can hopefully the demo will be set up and we can go from there. This is one part of, let me see, let me get this up. Here we go. So this highlights the HP Smart Drive, and one of the key components of that is the do not remove indicator. So one of the things that we did in preparing for Gen 8, and we do on a regular basis, is all of our engineers go through all the outage reports that come in from customers. And obviously, we take data protection very seriously. And even when it's something that it ends up being a human error, we want to make sure we address that. So in this case, we had multiple customers on a weekly basis were experiencing data loss because someone pulled the wrong drive from the RAID set. And so what we just thought about it, said, what can we do to address that? And one of the things that the thing that we came up with is this do not remove indicator on the drives itself. And so if a drive has got live data on it, and if you by removing that disk you would lose data, we pop up a indicator on the drive itself that actually tells you do not take this drive out. So anyone walking into the data center, so like you can turn on, you saw the blue LEDs on the front of the drive. You can indicate what the RAID set is, and you know that there's a drive failed. But when you walk into the data center, what was happening is occasionally somebody was pulling not the drive that had failed, but one of the live drives out of the RAID set. That will not happen now. We actually have got the do not remove indicator on there to actually protect customers from that accidental human error of removing the wrong drive. And that's part of our demo here too. So we'll get to that. You ready?
I am.
Okay, and let me introduce, this is Scott Bunker. Scott works in our smart storage engineering organization, and he's going to be walking us through part of the demo here.
Okay, well, welcome guys. I'm glad you could join us at HP. Let's see, is there a way that we can
Yep, we can take
get
this.
the video up on the big screen here?
Yep, take that.
Okay, so if you guys are anything like me, you enjoy playing with the technology, and got a couple of things I can show you. And of course, if you guys want to see something particular, just ask, and we can go and explore that. McLeod, was there any other slideware?
We got a
that
few
need to
more
reserve
slides,
toward
and
the
we
end?
can come back to that. I
Okay.
want to make sure that these guys get a chance to see and use the technology and see it work. So.
Okay.
Yeah.
So I'm in the smart storage organization. I've been doing that for about 15 years now. Seen many generations of our smart array controllers get developed over the years. This generation of controller, the P42X series, we are exceptionally proud of. We believe we've got the right recipe for performance. As McLeod mentioned previously, in terms of IOPS, the RAID controller's got a CPU processor in it, and that processor's got it's got a certain capability for delivering I/O operations to the back-end disk. So if you compare this to our previous controller, the the P410, P411 generation array controllers, we could generally do about 60,000 IOPS to the back-end hard drives before the controller CPU processor would saturate. With this generation of controllers, we've made the processor faster. We've got additional cores inside of it. We've optimized our firmware for the I/O path to the rate controller itself. And as you can see demonstrated, the fruits of our efforts, we're hitting 206,000 IOPS off a single smart array controller. Now on the back end, I've got 8 solid state drives that are delivering these IOPS. And the workload that I'm running here is it's just a 4K random read workload. So you know, about a 4 to 1 ratio, 4x improvements in the I/O capability of the array controller. Now, when you look at IOPS of the array controller, those are physical drive IOPS, so those wouldn't be like a logical drive IOP on the front end. And a good way to think about that, you know, to the RAID 10 ADM question earlier, there's 3 I/O operations to complete a single RAID 10 ADM write because we have to mirror the data to 3 disks, and so that taxes 3 IOPS of this controller capable of 210,000 IOPS for a single write operation. RAID 5, you know, just kind of get a feel for it. RAID 5 is 2 reads, 2 writes. If you're doing a backed out write operation, so it's 4 I/O compared to 3 I/O with the RAID 10 ADM. And to the gentleman's point, RAID 10 ADM is still faster than RAID 5. One of the other beautiful things about RAID 10 with ADM is as you build up your array and you go larger, taking advantage of the many different front cage option. I think McLeod showed 5 front ends that you can put on any 2U server, which is pretty incredible. But as you add that many spindles to the front of your server, if you have RAID 5 or RAID 6, you know your fault tolerance is going to degrade as you add more spindles to a RAID 5 or RAID 6, because your parity drive to usable data drive ratio gets reduced as you make that array larger. But the beauty about RAID 10 and even RAID 10 with ADM is that your fault tolerance remains relatively consistent as you make that array larger and larger, because you're building up the same number of parity drives as you are building up usable capacity. So you get to maintain a certain level of fault tolerance, and it remains relatively flat by increasing your spindles. A couple of other important metrics here. You know, as a RAID controller designer, there's a couple of things that we metric ourselves on. So read operations, we're typically passing that directly to the disk, and you know, the RAID controller, you know, generally should not come into play. You should not see the RAID controller as any sort of limiting factor. And so read I/O is pretty basic. It passes straight to disk until you hit an IOP ceiling such as this. And you know, again, the RAID controller is demonstrating 210,000 IOPS, which is pretty incredible. But the other side of the metric that we like to keep our eyes on is RAID 5 and RAID 6 write performance. Generally, what happens there is in a RAID controller, you have a memory subsystem that's calculating the XOR, the parity data for your drive on the fly. That data is moving through the RAID controller, headed to the disk. We've got to intercept that data, calculate the XOR, and then by doing 2 reads, calculating the XOR, and then we write your regular data, plus we do a second write to update the parity data. So we keep our eyes on the our XOR engine, our DRAM bandwidth, to make sure that we can keep up with the performance as we're performing those writes. Particularly with our P42X generation of controllers, we have increased our RAID 5 and RAID 6 write performance by about 2x. So if you look at it with the previous generation, the P410, we were pushing about 1 gigabyte per second, give or take a few. And with this generation controllers, we're pushing over 2 gigabytes per second. So we've doubled that bandwidth. And so increasing our IOPS by 4x, by doubling our DRAM bandwidth, that's how we've optimized for the explosive performance that is available with solid state drives. So we can change it up a little bit. Let's do a couple of other demos. Let's bring up the array configuration utility. This utility has changed in appearance a little bit over the years, but it's had a relatively constant look and feel to it. So let's start off. We're going to clear the configuration that we have right now. And what we have available to us are 8 solid state drives, and you can look at it from an enclosure view. We got 2 SAS cables. We have 4 drives attached to each SAS cable. If this was a JBOD, you would actually see, you know, the JBOD or the expander with the drives that are attached. So you kind of get a physical view of where the drives are in the system. And first thing we need to do is create an array. Let's go ahead and create an array out of all 8 solid state drives. Our next step is to create a logical drive. Now, one thing you'll notice here is that RAID 10 with ADM is not present in the view. Just like how RAID 10 requires an even number of drives to be added in the array before RAID 10 becomes available, just like how RAID 5 requires a minimum of 3 disks before the RAID 5 option become available. RAID 10 with ADM requires an increment of 6 drives in order for that option to become available. So let's let's select all but 6 drives, create the logical, and now RAID 10 with advanced data mirroring is available because we have an increment of 3 drives with 6. Okay, so now we have a RAID 10 with ADM. See a couple of the advanced options that we have here. We could split any mirrors, a RAID 10 with advanced data mirroring or a RAID 10. You can split that mirror. That's commonly useful for cloning boot drives. A lot of our customers need a very efficient way to start off with a RAID 10 mirror in a server, split it, move the drive to another server, and then join it back with the RAID 10 mirror and clone it. So that's one of the features that you see up here on the display. We also can assign global online spares to this RAID set. From the controller setting standpoint, you can change your transformation priority, rebuild priority, and your surface scan. How aggressive the RAID controller checks for unrecoverable read errors and repairs them using the RAID fault tolerance. From the cache settings, you can enable or disable the flashback write cache on a per logical drive basis. Previous generation controllers, we offered, you know, a mixture of battery back write cache and what we call flashback write cache. With this generation of controllers, we offer flashback write cache across our entire product line. So with this generation, we have no battery back write cache solutions. We have made the full transition over to flashback write cache, where your data is safer in case of a power outage for a much longer extended period of time, because your data is not held up by the batteries at that point. Your data has been moved over to the flashback write cache, being held up by a super cap during that very short transition period. And then once it's in the flash, then you have the resiliency of flash to hold your data for a very long period of time.
Can you explain the transformation priority you mentioned in the previous screen?
Sure. So the Smart Array RAID controller development team was looking for a generic term that would convey a multitude of features. We have features like a RAID migration, to where you can migrate this RAID from RAID 10 with ADM to a RAID 5 to a RAID 10. You can change your RAID without necessarily doing a backup or restore. The Smart Array team calls that a transformation of your data. Very similarly, you can change your stripe size. If maybe a larger stripe size would kind of optimize some of that big block read performance, and so you want to change that stripe size, see what the improvement might be, you can transform your array to a logical drive with various stripe size. Now this is different from rebuild priority. You notice up here that there is 3 settings: transformation priority, rebuild priority, and surface scan priority. So rebuild, as we know, is after you service the drive, how long it takes for that drive to rebuild. And for the priority, it's basically a customer selection of how much priority do you want to give toward host I/O, because the server is still serving a need, in your environment, in your data center, versus your fault tolerance concern of getting that RAID set back to full fault tolerance. So you may want to change the dial to speed up the rebuild, or let a little host I/O take priority because I need a certain amount of availability of my system. And so you have those dials in place. There's a RAID migration. There's a stripe size migration. You can also do capacity extension. This concept where if I created a 6 drive RAID 10 and we wanted to go to a 9 drive RAID 10, we can just go in through ACU and tell the controller, and it will create the same size logical drive, but it will just extend that to 3 more deaths, so that you've got more spindles partaking in the read and write I/O operations. We also have a logical drive expansion, which is another example of a transformation possibility, to where you could say, okay, created a 6 drive RAID 10 with ADM. Initially, I made a 50% of the array for a logical drive, but I need more space in that same logical drive, so you can go ahead and extend it, and the RAID controller will go ahead and let you extend it. So there's lots of examples, but hopefully you kind of get what I mean. There's a lot of transformational type features, and the Smart Array team was looking for that generic term that would kind of encompass all those things. Yes, sir.
When you're looking at this right now, the way it's set up with RAID 10 with ADM, there's a lot of overhead from a capacity perspective, especially with 8 disks and 2 hot spares. But are you doing any data reduction, deduplication, or anything like that to try to optimize the capacity, or is that not beyond the scope of the product?
It's beyond the scope of the product. Okay. So the Smart Array controller, if you're running RAID 10 with ADM, you got 33% usable capacity. RAID 10 is 50% usable capacity. RAID 5 and 6 is a function of how many disks is in your array.
Right.
But they're in the Smart Array controller. What you'll find here in ACU, you'll not find any of those types of thin provisioning or deduplication type features available.
Yeah, you would just be provisioning. You set the max capacity, right? But there are other products from HP that do dedupe. So
right. You'll find those in sort of a lot of the shared storage products that we offer up. Good question. Any other questions?
It's about the rebuild speed time. You know anything about that?
The rebuild, we have a couple of features that we've lumped into rebuild. They're not necessarily new to this generation. I think they got introduced in the previous generation, called rapid rebuild technology. And I could be mistaken. It could have been the generation before that. But I could articulate and help describe what all is involved in rapid rebuild technology. Smart Array has several patented features when it comes to rapid rebuild. One of them is this concept where we can take a logical drive and track which regions of the drive you have written to. And whenever you replace the drive and begin a rebuild, we know that we only need to rebuild the regions that you have previously written to. Obviously, if you have not written to a region of that logical drive, there's no important user data there. And so we can go ahead and complete the rebuild operation sooner rather than go through uninitialized area of the drive that hasn't been accessed yet. Plus, there's a couple of other techniques that we've done throughout the years. One of them is when we rebuild take a RAID 5 logical drive for example. If you've created a small stripe size on that RAID 5 logical drive, a more traditional approach would be to rebuild on a stripe by stripe basis. The smarter array controller goes ahead and rebuilds no matter what your stripe size is, it will go ahead and grab potentially multiple stripes and run that through our XOR engine to calculate the parity and help rebuild that drive quicker. So there's lots of innovative type technologies that we've done to help increase the speed of rebuilds. Now, starting with Gen 8, we've got a very cool feature, which is the predictive spare activation. And so that, coupled with smart trips, could help you avoid the rebuild operation altogether. So if you look at G7 and we think about, okay, if I walk to my data center and I see a drive that's got a smart trip, you'll see the blinking amber light, to help notify, hey, there's a smart trip. You'll get notification in your system event logs through the MOM alerts, through SMNP traps. You'll get notified. But what do you do about it, right? So the first thing you do is you got to go and order the replacement drive, and you got to pull out that drive that's got a smart trip and replace it. Well, when you pull that drive out, you have reduced the fault tolerance of your logical drive when you take that action. And when you replace it, your fault tolerance is going to remain degraded depending upon your RAID level. RAID 6, you're not completely degraded, but you're reduced. But you're going to be reducing fault tolerance until that rebuild can complete, using all the HP advanced technology that we have to try to speed up that rebuild and make it as fast as possible. Now, play that out and with the Gen 8 technology, the predictive spare activation. If you've got a smart trip drive, you don't have to pull that drive out and degrade your fault tolerance, nor do you have to go and trigger it in ACU. It's automatic. You could set this thing up in advance when you create your RAID volume to take any number of global online spares. So if you've got 64 logical drives and you've got a bucket of spare drives somewhere, you can assign all of them to act as global online spares for any one of those 64 logical drives. And the smart array controller, as it detects smart trips on any one of those 64 logical drives, it will go ahead and pull out a spare like a Pez dispenser and go in and use that spare. And instead of rebuilding the data to that spare, well, that smart trip drive is still available. They'll just go ahead and copy that data to the spare drive. And whenever that copy is complete, we will mark that smart trip drive as a failure so that you know that it's been taken offline. It's not part of the RAID set anymore. And you can now safely service smart trip drives without worrying about reducing your fault tolerance. I feel that that's a very cool feature because you're if you look at the mean time till data loss formulas, it's a function of your MTBF of your RAID plus your mean time between repair of that rebuild. And so there's two ways of attacking it. You can try to reduce the mean time between repair, or you can use predictive spare activation and help dynamically repair on the fly as smart trips happen with the drives and improve your MTBF. Okay.
Can you show them the do not remove indicator? Or?
Yeah, let's. So we have a RAID 10 with ADM. Let's see.
You can turn it so you can get the camera.
Drag some power cords behind me.
Don't worry about it. Let me
Is that a good spot for you? Okay, we've got a new carrier on HP drives. We call the entire drive assembly now a HP Smart Drive. Smart Drive being one word. And we've added enhanced LED displays on the front of this drive. The purpose of that is to make the drive status more intuitive. So, as IT personnel, you guys are probably familiar with HP's previous generation of drives, and so we had some LEDs on those drives. Those LEDs were not labeled on the carrier itself. There's a reference material that would describe that an LED, one of the LEDs is logical drive configuration activity, it's multiplex, and the other light pipe was indicating drive failures, smart trips, and locate. What we've done in this generation is we wanted to provide a more intuitive feel for what is that status telling me. And so we have icons on every single LED. We're backlighting those icons, like the do not remove LED and the hard drive status. It's a stack of spindles. The locate LED is, we're now backlighting behind the handle, so you kind of got this cool backlight feature. Get more blue per square inch on the front of the server, so you can help identify and notice, there's a locate, instead of having a small dot. For the do not remove feature, if you pulled out a drive, the do not remove feature would light up to let you know that removing this drive will result in a logical drive failure. Obviously, with RAID 10 ADM, we can sustain a two drive failure. And so take a moment for the controller. So in this case, the controller, I created a spare drive, and the controller has kicked off a rebuild to the spare drive. It's kind of clouding the status here. Let's
You guys want to get closer look?
Yeah.
Stand up and get closer.
spare management. Okay, it's got a rebuild in progress, so it's not going to allow you to. It's not going to allow you to change your spare mapping at this point. Let me replay this demo, but without the spare drive, so that you can actually see, what it looks like whenever a drive faults. I got an unassigned drive in there. Okay, so it's got an odd number of drives, so it's the RAID 10 and RAID 10 with ADM. It's got an unassigned drive up here. So if you look at the spindles I have selected, I got bays 2, 3, 4, 5, 6, 7, and 8. And bay 1 is unassigned up here. So I got a 7 drive RAID 5. So bay 1's unselected. And if we were to fail any one of the drives, the RAID controller would detect that the remaining drive sets, because it is RAID 5, should not be removed. Obviously, right? You pull out a second drive in a RAID 5, you'll cause a logical drive failure. So the controller immediately expressed that these drives are the remaining drives in the RAID set and should not be removed. Can you guys see that? Mm-hmm. Okay, let's do another example. Kind of nice when you don't have just give the controller a moment to detect the drive I just inserted. There it is. Okay, we're going to select all 8 drives now. And RAID 10 with ADM will not be available. We talked about that earlier. It's got to be an increment of 3. We're going to go ahead and do a RAID 10. You can see as I select through the drives that it's turning on the locate LED, the backlight behind the handle for each drive that I select. So if we start through and walk through all the drives, there's bay 1, bay 2. And so whatever you do from the array configuration utility, from the Orca utility, the locate LED will model your mouse movement so that you can see intuitively exactly what you're selecting. Now, the thing about a RAID 10 with ADM, the thing about a RAID 10, this is a 2-drive mirror, is you don't always know where the mirrored partner is. The smart array controller generally will mirror drives based upon bay order. So you'll find drives on the left being mirrored with drives on the right. And since this is a RAID 10, I held this drive, pulled it out, it's in our hands now, it's obviously fell. And you can see that bay 2 was the partner drive for that RAID 10. Unlike the RAID 5 where they all lit up to tell you, do not remove, with the RAID 10, it's only one drive that you shouldn't pull out because it will cause the entire logical drive to fail. So to help highlight that, we place that icon right on the button, right the spot where you would touch to eject the drive, and pop the handle open. We thought that it's, again, trying to drive an intuitive feel to it. Place the LED right on the touch point. We can go ahead and pull out other drives as long as the do not remove LED is lit on that drive. I have, at this point, I have not
It doesn't lock the touch point, does it?
It doesn't lock it. It just gives you a visual indication that if you remove this,
Don't touch it.
yeah.
So you can still be stupid.
Yeah.
Really stupid.
Blind and stupid.
For Gen 9.
Now, is there?
The capability to where you can, basically, if you're telling somebody to replace a disk, you can highlight which disk you want them to pull out and have that light flash.
That's the button that you're not supposed to remove.
There's
So-
something that you showed and I missed.
Is there an open seat now?
So you can see here that bay 6 and 7 is failed, but for instance, if you wanted to tell somebody to pull out bay 1, you can turn on the locate LED by
Okay.
selecting it
Alright.
within ACU. Additionally, you can go to like the system management homepage, and you can tell it to turn on locate LED, but it will also allow you to specify for how long. So if you want to turn it on for 30 minutes and then automatically go off, it's got those capabilities in it. So you can see that we've got drive bays 6 and 7 pulled out, and drive bays 2 and 3, their do not remove LED has appeared on the button. One of the other nice things about the do not remove LED is we've designed this with in-mold decorating. It's a special plastics process where when the LED turns off, there is no image of the icon left on that button. So it's not going to confuse you by seeing, the background image, an unlit image in the background. We've totally masked off that LED. So it's not until we want the do not remove icon to appear, you have this sort of this soft white imagery of the do not remove. It's graphically it's the do not eject symbol with sort of the circle with the slash through it. So it's the anti-eject type symbol, do not remove. And what it basically means is that pulling out the drive will result in a logical drive failure. So to McLeod's point earlier, hopefully by putting these things on the drive, we have helped guide customers, operators from touching buttons and removing drives and resulting in self-induced logical drive failures. In addition to that, we have logging capabilities in the new smart drive. It's got a log kept in the background. That log does not hold any user data. There's no data that would describe, the customer should cause any concern for security. What that device logs is information about the controller that it was attached to, the drive bay it was installed into, the current temperature reading of the drive, the controller firmware version, a couple of serial numbers involved in that log. So it helps improve the information as as the drive fails and gets returned back to HP. We've got more information about what sort of environment that drive lived in at the moment that it failed, to where it will help us better to make the necessary improvements to help prevent, bring it back full circle, help us to improve the process to help reduce failures in areas that we could improve upon.
Yeah, that's part of the active health system, and it's part of the faster problem resolution equation in terms of I think the number that we talked about is 66% faster problem resolution, and it's all of that's really driven out of the fact that we have this integrated intelligence around the subcomponents of the system integrated with the ILO management engine to give you that active health capability and to pass forward that information. Not just in the hard drive, but also in the memory. We have the HP Smart Memory capabilities. If you look at the Smart Memory, it's got the same kind of indicator where you can tell temperature, you can tell exactly what happened with that system. You can tell configuration information and historical configuration information. If someone's changed DIMMs, changed the memory configuration, you can go back as the administrator of that particular piece of hardware. You can actually go tell what exactly is going on. One of the great things, sometimes ECC errors can be thermally triggered, so it may be dependent on the environmentals of that particular system, where it was operating, that you might be seeing some errors. And so when you take it out of that environment, you may not see those errors again. So active health system would actually allow you as a user and as HP, the service organization supporting that user, to be able to tell exactly what environment that system was in, to be able to go back and duplicate that and actually resolve the problem much faster, as opposed to going back and forth with, I found the error, I've experienced it in my environment, but then I take it out of that environment and I no longer see the error. You're able to actually resolve that issue much faster. So really cool technology, really kind of embedded in every single component within the system to really go help customers address and resolve issues as they do happen much faster than has been possible in the past and across other products in the same category. One of the other things, a lot of the intelligence built into the Smart Array, that we call it Smart Data Services. And really that's a foundation for a lot of things that we're going to be doing as we move forward. It's workload intelligence and workload aware intelligence, where we can actually see the types of workloads running on the system. So for example, if you're running a virtualization environment and those virtual machines contain sequential data, we can actually look through that virtual machine, because it would appear as random data on the surface, but we can look through those virtual machines and see that sequence data and actually the sequential data, and actually resequence it and optimize the performance of the system through that intelligence. And what does that give us? I mean, in the short term, it's given us performance gains and improvements, but also longer term, it really allows us to lay down a foundation for what we call smart caching, which is the ability to actually tell the most frequently accessed data, move it to the fastest possible media, and then move the stuff that's not accessed as frequently off to slower rotational media, which really kind of optimizes performance, capacity, and the cost that today is prohibitive. If you've got a lot of data and you need that performance, in a lot of cases you just can't afford it, because trying to put that much solid state behind the system is very expensive at the capacity levels that you would want to go drive it at. So the smart data services and smart caching are really, if you look at HP, we're in a unique position because we own the RAID stack inside the server all the way out to the shared storage. If you look at 3PAR, and being able to drive that end-to-end solution from not just in the shared storage or not just in the server, but actually being able to take these technologies and connect them together and deliver an end-to-end solution all the way out the shared storage. And that's really the foundation that's been laid with ProLiant Gen8 to help deliver on that promise and on that vision of where we're going with our storage.
Question with the actual drive tray. If I have a Gen8 and I want to put a different drive, can I put other drives in that tray, or does it have to come all prepackaged? So if I want to put a different SSD manufacturer that you guys don't always have, can I put another SSD in there?
So all of
and will it still support it?
Yeah, so everything's integrated. So and I should have talked about this with the memory piece too, and the hard drives. We go through and qualify and test all of the different manufacturers, and it's a very rigorous process. And so only basically the creme de la creme, the top level components actually make it through the test process. And when we sell the smart drive is actually all married together. The drives come together. We support multiple vendors on the back end, but all the testing has been driven through us, and there's certain enhancements and updates that get done to those components to meet our standards that are part of that. So no, you wouldn't be able to just order a carrier by itself and order a drive and pull those together. One of the other things we didn't really talk about too is one of the things about this is there's actual counterfeit protection for customers so that they don't get drives that haven't gone through the qualification process, that haven't been tested, that get stuck into a carrier and put into the system. They can actually tell if they've got a drive that wasn't an HP tested drive in the system. And through that counterfeit protection and the intelligence built into this carrier.
What happens to it if that's?
You still get normal function. You don't get some of the more advanced features that you would get from the HP drives that have been qualified, but you get normal function of the drive.
So I'm more thinking like if down the road. So if I had one and a year down the road, a newer faster SSD or something came out, and I just wanted to replace it, but I didn't need to replace the whole chassis. If I could just replace the drive in the tray.
Yeah. So typically, that's an event. You got to take it out. You got to do something. Typically, we work with customers to go work that out, right? I mean, that's usually not an issue. Typically, they would the overhead of removing a drive and putting it into the carrier and all. It's just easier to get the newer, updated drive in the carrier and just do a swap, right? So
there's a cost benefit.
Yeah.
Well, that as well. So.
McLeod, we're almost out of time.
Yep.
Did you have other slides you wanted to show, or you?
Yeah. So the only other, let me just kind of
the video.
Wasn't sure if you want to or not.
Yeah, I talked over some of the slides. I just didn't even show the slides. But what I am gonna show here is the kind of culmination of all this stuff coming together. There's a couple of leadership slides, I guess you could say. One on in terms of just recognized technology leadership. The number of awards, the products across the portfolio. This isn't just Gen8. This is just kind of historical ProLiant, and there's a number of these still coming with the new generation of servers as well. But then this slide really goes to the ProLiant Gen8 and the benefit of all of this innovation, and we're really seeing the results from that. And that's number one in a lot of categories from an application performance standpoint, and that's really what matters when we start talking about this category of technology. Really, the driving force behind it is how do I make my customers' applications run faster, more resilient, and at the capacity levels that they want or need for their applications. So I just wanted to leave you with this slide. This is a really good kind of wrap-up slide from the standpoint of this is what really matters is this and in the customer's environment, seeing their workloads and their applications running faster. You've got a copy of this too.
Okay, perfect. Thank you very much, McLeod.
Yeah.
And
Thank you guys for taking the time to be here.
yeah.
And I think I kept everybody awake. Nobody went to sleep. So that's good.
It's a good job, right?
Yeah.